Hello everyone, good morning and welcome again to our online science class. Today is May 5th, 2020. How was your week so far? Are you doing great? That is awesome. So today we're going to have an exciting topic. It's about light. We're going to take a look about different properties of light for the day. So kindly get your course book, your pen and notes with you. If you don't have them, click the pause button right now and grab them. We're going to need some pen and notes for note-taking, important concepts for the day. So please get them. If you have them all, I think you're ready. I'm going to give you here some mind-boggling pictures to answer, and I need you to sharpen your eyes and look carefully at this. Here's question number 1. Identify which animal has this eye found here. Well, time is up. Let's see if you get it correctly. It's really easy. It's just a shark. Question number 2. Look at this very carefully. Let's see if you get a correct answer. Did you get it? That is awesome. Here's question number 3. Let's see if you get it correctly. It's just simply a tiger. Here's the next question. Can you guess what is it? Take a look. Did you get it correctly? Well, here's the last question. It's pretty tough, but it's just simply a butterfly magnified. So how much you get so far? Please let me know on the comment section below. Please write your mark. So we're talking here about eyes. So what do you think is our topic for today? Well, eyes is said to be the window for the soul, and that is where we perceive or where we see light. So our topic for today is all about, simply we're still about light, and we're going to take a look here, how does reflection form? As well as we're going to take also a closer look here, if light, does it always travels in a straight line, or is there any possibility that the light can bend? And we're going to define those two terms here, reflection and bending of the light. So if you have your course book, you can open it on pages 150 to 151. We're gonna take a look here of these two following concepts. We're going to analyze here the path of light during a reflection, and we're also going to investigate the change in the direction of rays during a refraction. We're going to define here, we're going to take a look here what is happening to the light during, number 1, reflection, and number 2, refraction. So let's just review one of the concepts that we learned last time about the formation of the shadow. So when light strikes, definitely it travels in a straight line. So how does a shadow form? So shadow forms when a light strikes an opaque object, and of course, shadow will be formed in just right over there, and I think you're doing that a lot of time when you want to play with your shadow. But however, when the light bounces off, I want to take a look of this word right over here, bounce. Okay, it bounces off. A reflection tends to form. So, what is a reflection? So, take a look with reflection deeper. Let's answer this question, and let's investigate the materials right over here. I have there 7 materials, and I want you to identify which material there can reflect light. You can answer multiple letters here. You have A, B, C, D, E, F, or G. So which you think here can reflect light? Alright, so I think that you have the answer on mind. Let's take a look with your answer. So actually, all of these materials reflect light. So the moon, the car, even the clothes and the table, and even the paper there reflects the light. And obviously, the mirror at the top reflects the light. So why these materials are said to reflect light? One is that because we can see the image, we can see the moon, we can see the spoon, and we can see the paper. So the moment that we can see the image, it means that light is reflecting on it. So we can't see this object unless light will be reflecting on it. Plus, we can see the colors, and if you take a look with the clothes right over there, so the moment we see the colors, it shows that those colors are the ones which our eyes are perceiving, or our eyes can see. So we're going to take a look here why we see colors in our next topic that will be next week, so hang on with that. And plus, we know that all of these materials reflect light because of the very reason, that's right over here, it is visible. That means we can see those objects. So since we're talking here about reflection, let's take a look what is a reflection. And I have there some of the examples. We have there, I strike the light in a mirror, and I strike the light on the paper, and try to see the difference on the reflection. Well, on the paper, reflection happens, but take a look with that of the mirror. So what difference can you see? In a mirror, just right over there, the plane mirror or any other surface which is smooth produces a reflected image. So the reflected rays there tends to be of an angle, and it tends to be straight, and it's only on one focus compared to that of a paper. So in object like a rough object just right over there, try to look at the reflected rays. It tends to be scattered. So in any way, these two, regular reflection and diffuse reflection, are just both reflections. So what is a reflection? So simply, reflection is just a bouncing off of any light, and that's what we call reflection. So we're going to predict right now what will happen if light is reflected. So we're going to predict here the path of a light using a plane mirror, and we're going to show later here how does a plane mirror would look like. But here in this experiment, they have a glass bar, and a mirror just to test what will happen, and they have a laser. So we're going to observe here the angles formed by the ray of light. So please write your observations in a piece of paper, or you can put it in the comment section below. So we need to identify these following words right over here. We have the incident ray, the reflected ray, the normal, the angle of incidence, which is related to the word incident ray, and we also have there the angle of reflection. So this is just an experiment right over here. I'm going to give you the YouTube link of that. I'm going to show you here a simulation of what will happen. So by the way, what we can see here is the angle of the incident ray. It is the light that we flash on the mirror. And this one is called, of course, the mirror, and this one now is the reflected ray. So the one here at the middle, here in this experiment, they use a protractor to identify the angles which are formed. So the angle which is formed by the incident ray is called the angle of incidence, and the angle formed of the reflection is called the angle of reflection. And found here at the middle, where no reflected ray is formed is called your normal. Alright, so I'm gonna show you here an example of the simulation of this. Well, let's take a look with this example. I have the mirror right over here, and I have this object. This is the eye. So, this one, look at the image which is formed here. The H here speaks about the distance between this one, and this is how we perceive it. Okay, so the angle here which is formed here is the incident ray, the light coming from this object. And of course, this is a reflection. And this one now is a reflected ray. And this is how we look at it. So try to look at the angles here. So the angle formed here is called the angle of incidence, since this is the angle formed from the normal, from the vertical. So if you do it with the vertical right over here, this is the normal. Okay, so this is now your angle of incidence. And this one now is your angle of reflection. To easily understand that, let's take a look with this ray over here. So I'm gonna turn it off. I'm gonna put a ray of light over here. I can press wave on it so that it will show that it's a wave. But I'm gonna put ray in here so that it's very easy to see how about the angle. So this one is, let's say, a glass. So the light tends to reflect in here. So this one, the light coming from the source is called the incident ray. And this one, the reflected light coming from the mirror or from the glass is called the reflected ray. So the one here at the middle is called the normal. So if I put it in the normal, it separates the reflected ray from that of the incident ray. So right now, let's take a look what will happen if I measure the angles. So try to see angles are formed. So let's put the protractor right over here. So I think that you have it, and you can try this at home. If you have a laser light or a beam of light thin enough so that you can measure, or you can put a line in it. So let's set it on 60 degrees. Okay, so look, the incident ray passes through 60 degrees. So the angle formed between the normal here and the incident ray is what? It's 60 degrees. Okay, it's formed 60 degrees. So let's try to see also what happens to the angle which is formed on the reflected ray. So again, this is a reflected ray, and look at the angle. What can you say about the angle? Is it equal or not? So it speaks about the law of reflection. So I have here, this one is a mirror and this one are just reflected light, and try to see what will happen. I put it all, okay, I put it just like this. Try to look at the angle. Well, it's very hard to look here and to predict here the angle because you don't have a protractor. However, if you're using this one, you can put it like this. Let's put it 30. Try to see what will happen. Okay, this one is a reflector. We're gonna take a look later what is this one. So just hang on with that. So this one is the reflection. The light passes up. Look at the degrees. It's still 30. I'm gonna put it somewhere between here. Probably this one is between 60 to 30. So probably this one is 40. And try to look at the angle. So what is a law of reflection? Law of reflection says that the angle formed by the incident ray, just right over here, is always equal to the angle which is formed by the reflected ray. So the angle of incidence is equal to the angle of reflection, and that is what we call Snell's law of reflection. It was discovered by Snell, a scientist, and sometimes we call that Descartes-Snell's law of reflection. So to identify the law of reflection, we have been using there a plane mirror, and that's why you can see there a reflection. And again, the angle of reflection is always equal to the angle of the incidence. So let's try to use a different mirror, and the one which I'm using here is said to be a concave mirror, and try to see how does the concave mirror would look like. And later on, I'll be asking you what is a real life application of this kind of mirror. So we're going to describe here the image is formed if the object is moved. So the letter C here is the curvature point, and the letter F here is the focal point. So just hang on with those words. It's not important as of this moment, but these are just the point at which we move the image, okay? And later on, I'm gonna ask you what happens to the image. So please prepare your notes with you, so take down the different things that is happening right over here, okay? So here's the first case. I'm going to put the object here, which is the candle. Again, this one is a concave mirror, okay? So I'm gonna put the candle beyond C, so it's as far from C. So what kind of image do we see in here? So the red line here is the incident ray going to the mirror, and this one is of course a reflected ray going here in the air. So we're just in a plain air. So describe the image that is formed. Okay, this is the first question. Do we see the image on the mirror? No, we don't see it. We see it outside actually the mirror. That is a really great job. That means this image here is said to be projected. That means it's outside the mirror. So what can you say about the image? Well, the image is between the C and the F. It is inverted. It means it's not of the same position, just like this one. And of course, is it big or small? It's reduced in size. It means it's smaller. Well, let's do the case number 2. We're gonna put the object at C. What have you observed about the size? Well, it's an inverted image, and the size is similar. Well, it's a little bit bigger, but it should be similar, and it's the same place where I put the candle. So let's put the candle between C and F. Look at the difference of the image. So what can you say about the image now? So you put the candle right over here between the curvature, a point, look here, and the focal point. The focal point speaks about the focus here. So what image do you see? The image is said to be inverted. That's good. And the image is magnified several times in that of the original. Let's try to see what will happen if we do the case number 4. The object will be located in F. What happens? Definitely no image will be formed in here. Why is that? Because we put now the object in the focus point, and the image now is beyond the focus. The image now is the reflection in the incident now is happening just at the surface of the mirror, and that is the reason why we cannot see the image. Well, let's put the image far from F. Look at what will happen. So where can we see the image now? We can see the image on the mirror. That's why when you go near a concave mirror, you can see the image on the mirror itself. But if you go far away, it's projected. So the image that is formed here is magnified several times. It's bigger. Plus, it's an upright image now, not or unlike if I put it beyond C or beyond F, the image is said to be inverted. At this time, let's take a look with a different mirror. Here, we're going to use a convex mirror at this time. So let's take a look what will happen. So right over there is a convex mirror, and try to see the surface of the mirror. And try to remember the shape a while ago of the concave mirror and how to reflect it. So I have here the candle, okay? So try to see. If I'm going to move the candle away from the mirror, look at what will happen to the image. Does it become bigger or smaller? Does it reduce in size or magnified? Or is it inverted or upright in position? Okay, so please write your answer on your paper, and we're gonna compare it with what I have in here. So the image is located behind the convex mirror. That means just right over here. You can see it there. So unlike with the concave mirror, if I put it farther, what happens is that the image tends to be projected. But here, it is behind the convex mirror. So right over, this is the surface, so it's found behind the convex mirror. Next is that it's upright. It's never inverted, even though I put it far away or near to the mirror. Plus, the image is said to be reduced. So what is the difference now between concave and convex mirror? So I have it right over here. The concave mirror, based on the nature of the image that is formed, concave mirror tends to be real except when the object is very close to the mirror. It's found on virtual. It's found behind the mirror. However, for the convex mirror, just like this one, all images are virtual. It's found behind the mirror. Look at also the position of the image that is formed. Is it upright or is it inverted? Inverted in concave, upright in convex, and the size also is different between concave and convex. For the convex, it tends to be diminished, the size, if I put it really farther away, but it's reduced. But for the concave mirror, it tends only to be enlarged. Okay, so what is now the real life application of this? So we usually, since our eyes is an example of a mirror, and try to look at this one, our eyes actually inverts the image. So, and it is reflected right over here at the back of our eyes. Okay, so I want to identify what part of the eye is that. That's a bonus point if you put it in the chat box what part of the eye it is. So there are two deficiency would have, or disease which occurs in our eyes. We have there the nearsightedness and the farsightedness vision. So we're going to identify here what kind of mirror are we going to use to correct the image of the nearsighted and the farsighted. Look here for the nearsighted, the image needs to be really near so that the person can see that. But here the farsighted, he can see the image clearly if it's really far away. So we need to correct that. Okay. So for the nearsighted person, take a look with this one. Okay. What image are we going to use? So if I put the image far, you cannot see that. So it's a near point, the image becomes bigger so the person can see that. So we need to use a lens. So let's put the image over here, the candle, and look. Okay, so corrected near point right over here. So the person now can see it clearly. Okay, so look at the mirror which is being used in here. Let's take a look now with that of the far-sighted person. So the far-sighted person can see the image far, so this is the near point or the normal vision. It needs to be in here. Compared to that of the nearsighted, the near point is here, so the person can see that. So we need to use this kind of lens to make the image clear for that person. So for the far-sighted, look at what will happen. Okay, if we put a lens and try to see the lens which is being used in here, so the corrected point becomes now here, so the person now can see it clearly. Okay, so I'm gonna press this one. So what part of that is the keys view more in the vitreous humor, which is really involved with that process. So which kind of material are we going to use in your convex and concave mirror? So for your far-sighted and nearsighted person. So for the far-sighted, we use convex or concave. Take a look with this one. So here, look, and here, look. So we're going to use a different kind of mirror for each of them. So I want you to take note, for the far-sighted person, we need to use here a convex mirror so that the image would appear larger. However, for this person who is nearsighted, we usually use here a concave mirror, okay, or a concave glass for the eyeglasses so that the person can see that. Well, in some cases, if we're using here a glass, since we're talking here about like glass and reflection, let's take a look with the one which I have there in the active form. So I put oil and water on a test tube, and I put the test tube there with oil on the inside the big beaker. Try to see what happens. Where now is the middle part of the test tube? Where do you think it is? So it tends to disappear, and the main mechanism for that to happen is called refraction. So what is refraction? So to identify refraction, we're gonna use here some piece of glass right over here. So I have here the laser, so I'm gonna turn it on. The laser is a light. So I'm gonna give you the website for this. You can actually make the use different colors of the laser here, which identifies different wavelengths of the light. So we're gonna use the red ones. So look, okay, this one is a glass, and try to see what will happen. They say that light travels in a straight line, which is identified by this. However, if I put it this way, okay, what happens to the light now? The light tends to bend. Okay, well, we'll use a different kind. I'll use a triangular one. So, look at what will happen. Okay, so let's put a circle right over here. Okay, and another one right over here. Alright, so, what have you observed? So, we call this now as a refraction. So, what is a refraction based on what we can see in here? So, just simply, refraction is said to be the bending of light. And it says here that refraction tends to change the direction of light, and it's really obvious. Okay, if I make the light's angle right over here, okay, or just right over here, oops, okay, what happens is that this one is a really nice description of what's happening during refraction. So there's a change of the direction of the light when it enters or leaves a transparent material. So how does that happen? Let's take a look with this one. Okay, so what I have here is a light. I'm gonna put it right over here. So this one now is a reflection, and this one now is a light. So this environment here at the top is the air, and the one here below is water. Okay, I'm gonna change the material here into air. Look at what happens. Light just travels straight. I'm going to make this environment as water, or like a glass maybe. Look at what happens now. So this one now is said to be your incident ray, and this one now is said to be your reflected ray. Okay, so do we form the same angle? This is a really first question, because a while ago for the reflected ray we have equal angles. So this one now is your reflected ray. So look, it's 60 degrees. This one also forms 60 degrees. However, for the reflected ray of the bending of the light, or the change of the direction when the light passes through the glass or the water, in this case it's water. So look at what happens to the angle. So this one is 60 degrees, but do you think this one is 60 degrees also? No, it's not anymore. If you look here, it's somewhere most probably 37 degrees here. So is it equal or not? So definitely it is not equal. So they say that light travels in a straight line, but here is my question. Why does it bend in here? And look at the material. So what probably might be the reason for this? So first is you need to take a look if these two have the same material. This one is air, this one is water. Try look again. I'm gonna make it an air, and if I fill it with water, look at what happens to the light. It tends to bend. So why does light bend? First is because light now travels in a different medium. This one is air, and this one now is water. Well, I'm gonna make this one at the top water. I'm gonna fill it with water, so they are just the same. Look at what happens now. The light doesn't bend, but I'm going to make this one below as the glass, and look at what will happen. So there is now a bending. So each of these tends to have a different indices. So light indices, so that means the index of the reflection of this on the air is different, or the refraction in the air is different, and the one on the water or on the glass is also different, and that creates now a difference in the angle between the incidence ray of the source of light and the reflected ray when it goes, in this case, the glass, and also the angle when it goes to the water. I'm gonna change this top and focus the air. Okay, look, it's something different now. However, if the material is just reflected here, because this one is just an air, so it tries to reflect in here, so the angle is just the same. The angle is different if it is now refracted. So I want you to take a look with this one here, and this one will explain, this concept here will explain what's happening here. So you can actually try this at home. Why does the coin disappear in here when I put it in the bottom of the glass and I put the water? So why? So simply because the coin disappears because the light, which is reflected from the coin here, travels on different medium. First, it travels in the glass, and after that, it travels in the water. So the light tends to bend in the glass and also in the water, and probably the bending of that might not anymore be on the angle of how we see the material, and hence it tends to become invisible now. So one example of that, and when you view a fish on the water, so sometimes, I don't know if you have experienced that one. So this one is actually the air, this one is the water. So the index of the water is 1.33 and that of the air is 1. Okay, so depending on your angle is where you can see the fish. So if the fish, if you, okay, let's arrange you in here. Okay, so you need to look at this image so that you will see where the real position of the fish is. Okay, however, if you move slightly upward, the index becomes different. So the actual fish is in here, but because of the bending of the light, you would see the fish at the bottom. So normally, if you are a fisherman or you want to catch a fish, or let's say you are in a swimming pool and you want to get something from it, try to notice. You tend to touch it, however, it's not there. You need to move your hand a little bit forward. Why is that so? Simply because the light tends to bend if it reaches the water in here. So that's the reason why birds and even human have a difference on the position when we catch a fish or when we see objects underwater. So those are about the refraction, the concepts about refraction. So let's take a look now with the difference between a reflection and a refraction. So I want you to bear in mind what happens to light during refraction and reflection. There's a difference, of course, and the angles that are formed between the incident ray and the reflected ray is also different between reflection and refraction. So I want you to write it in the notes with you, and let's compare your answer with me later. I'm gonna give you a minute to think about that, and let's compare notes later. Alright? So your time starts now. So time is up. So let's see. Okay, so I have here now the phenomenon on what happens during reflection, and this one is the phenomenon that happens during refraction. So when it comes to light, reflection is just bouncing of light in here, and refraction is said to be the bending of light. So there's a difference between the angles which is formed in the incident ray and the reflected ray. So reflection, the angle between incident and reflected ray is just equal. However, on the refraction, it's totally different. So these are just the kind of things that you need to take a look at. Alright, so if you need more time to review before we go into this quiz, hit the pause button and revise in the video. But if you're ready, let's crack the brain out and let's answer this question. Just identify here whether that phenomenon that I have here in the picture is a reflection or a refraction. So here's question number 1. It's simply reflection, so it's a kind of mirror. Number 2, what's happening here is a refraction, and this is our topic actually for our next meeting. So I want you to identify what is the name of this material, and look at what happens to the light when it passes through here. Number 3, of course, photography involves reflection. Next, number 4. Well, it's very easy. It's refraction. And here's number 5. Of course, this one is said to be refraction. So how much mark did you get? Did you get all 5 correctly? Let me know on the comment section below. So if you need more time or if you have questions, kindly let me know on the comment section below or send me a message about any clarification. Alright? So if you don't have any questions, so you can scan this QR code right over here. Use your phone. Just take a picture of that and it will pop you out on the website. Answer it. So hope that you enjoy our lesson for today and you learned something about reflection and refraction. So try to remember that and try to be very observant with the mirror around you, whether they are convex or concave mirror, and which part of your house refraction happens. Well, that will be all for today. Hope to see you and catch you on our next meeting. See you next week. Goodbye, everyone.